8.4. This is where we're going to do some tests involving paired differences that are dependent samples. So dependent means that you're using the same people for like the before and after. You're using the same objects to do a pre and post test. You're looking at paired objects. Now going through these, this is going to be a harder one to put into your calculator. It's still, you have to do nothing by hand. The calculator would do it all for you, but you have to remember these steps. So when we get to the calculator part, you need to make sure you're following along and you're going to practice this for 8.4. You have to make sure you use these steps as you go through 8.4 types of problems because it's easy to get 8.4 and 8.5 confused. So out of this whole chapter, 8.4 and 8.5 are going to be your two hardest sections. So you really need to make sure you are practicing how to type these into your calculator. Okay, so for our paired data pairs occur when there are before and after situations where the same object or item is measured both before and after a treatment. So for example 6, I have a shoe manufacturer claims that among the general population of adults in the U.S., the average length of the left foot is longer than that of the right foot. To compare the average length of the left foot with that of the right, we can take a random sample of 15 U.S. adults and measure the length of the left foot and then the length of the right foot for each person in the sample. Is there a natural way of pairing the measurements? How many pairs will we have? So when we go through this, if we want a natural way to pair the left and the right, you would then pair the left foot with the right foot of the same person. If we're looking at 15 adults, then there are going to be 15 pairs. So for these data, you need to make sure you have the exact same number in the first group and the second group because you're pairing your data when you go through them. So for 6, we'll look at this one, the next one, we'll look at that together too. So here we've got a psychologist has developed a series of exercises called the Instrumental Enrichment Program, which she claims is useful in overcoming cognitive deficiencies in children. To test the program, extensive statistical tests are being conducted. In one experiment, a random sample of 10-year-old student with IQ scores below 80 was selected. An IQ test was given to these students before they spent 2 years in an IE program, and an IQ test was given to the same students after the program. On what basis can you pair the IQ scores? If there are 20 students in the sample, how many data pairs will you have? So we would pair then the before and after IQ scores for each student. This means then that we would have 20 pairs because we have 20 students. Now again, in this section, they will talk about how to find things by hand, but like I said, we're going to use everything on our calculator again. You will not have to do anything by hand. So as long as you remember how to type things in, you do not need to memorize any types of formulas. With this section, you are going to be looking at a student's T distribution. That's because we will not have a population standard deviation. So when you go through this, you're going to be looking at a T test. So again, as we go through these, we're looking at 2 samples, and we're not given a population standard deviation. So we have 2 samples that have a S for the sample standard deviation instead of the sigma for the population standard deviation. So we are going to run a T test. Now it's going to be very similar to what we did back in 8.2, but we have a beginning part that's different. So this first part that I just marked by, that has to be done first before you can run your T-test. So you're going to put the before data in L1, after data in L2, and we're going to take L1 minus L2 and put that into L3. We then must run the 1var stats for L3. You must tell your calculator L3. If you do not tell it L3, you're not going to have the numbers pop up that need to pop up in your t-test. Once you do all these steps, then you can run your t-test, because your t-test will remember your last 1var stats that you ran. So it will take the numbers from L3 and use L3 to find everything for your X bar, your S, everything like that. Because when we go through with these paired differences, we want to run the t-test for the difference of the two columns, which is why everything is done with D, because D represents the difference between the first group and the second group. So we have to make sure that we find the difference and run our 1var stats with the difference from our groups. Okay, so for this one, they gave you a chart. Most of the time they are going to give you a chart. They won't always give you the difference. Most of the time they won't give you the difference. But here they did, just so we can check our numbers as we're going through things. So I have a team of heart surgeons at St. Anne's Hospital knows that many patients who undergo corrective heart surgery have a dangerous buildup of anxiety before their scheduled operations. The staff psychiatrist at the hospital has started a new counseling program intended to reduce this anxiety. Each patient is tested to determine their anxiety level prior to counseling sessions. Then each patient participates in a series of counseling sessions with the staff psychiatrist. At the end of the counseling sessions, each patient is retested to determine anxiety level. The table indicates the results for a random sample of 9 patients. Higher scores mean higher anxiety levels. Assume the distribution of differences is mound-shaped and symmetric. From the given data, can we conclude that the counseling sessions reduce anxiety? Use 0.01 level of significance. So we have the before counseling and the after counseling. Now, you've got to think what all this means. When we go through these, we are comparing our two groups. Before, when we went through for our null and our alternate hypothesis, we just had one letter equals for the null, and then one letter is either greater than, less than, doesn't equal for the alternate. Now, though, we are comparing two groups. So we have to, when we go through this, compare our two groups by their difference. So we have to subtract the two groups and figure out, for my alternate hypothesis, do I want my difference to be greater than, less than, or doesn't equal 0? Because it's what we're trying to find with our differences between the two. So if I'm looking at my before counseling and my after counseling, think this one through. If a higher number means more anxiety, you're thinking that after counseling, they should have less anxiety. So we want to find where the before minus the after is going to be greater than 0. Because we are saying the before group should have bigger numbers than the after group. Bigger number minus a smaller number should give me a number bigger than 0, a positive number. Because again, if we take the before anxiety, we want that to be greater than the after anxiety. So if you're not seeing this yet, we want the before to be greater than the after. So if I move my A over, B minus A is greater than 0. So that's how we're getting, we want before minus the after to be greater than 0. That's going to help us with our alternate hypothesis. Now remember, they told us there are 9 scores here. So when we go through this, our N is 9 because we have 9 pairs. Okay, so my level of significance. They told me my level of significance was 0.01. Now, when we write our null and our alternate, before we just use mu, but now we want the mu of the differences. So we're going to write it as mu d, because we're saying I want the difference of the means. So you're not going to write mu equals or mu less than, mu greater than, all that. It's mu d for these because you want the mean of the difference. Now, it will always be, for your null, mu d equals 0 because you're going to have the first null hypothesis that the first group minus the second group does not give us any type of difference. It's going to subtract the 2 and get a 0. One is not bigger than the other. That's our null hypothesis. Your alternate hypothesis is what we just found on the last page. We said before minus the after has to be greater than 0. So we want greater than 0. So again, it's mu d equals 0 every time because we're saying there's no difference between the groups. Your alternate then is going to be your difference is greater than, less than, or doesn't equal 0. Okay, so now to find the rest of our stuff, I'm going to bring my table back so I can see my numbers. So we have to go to stat, don't do test yet, stat, edit, clear out anything, type your numbers into L1, L2. Do not type in B minus A to L3. So don't start with 45 in L3. Leave L3 blank. Do not type any numbers into L3 yet. Okay, so double check your numbers. That's what I'm doing right now. Okay, so we're going to go up to L3. Now, when I say up, move all the way up so L3 is dark. You want to write L1 minus L2. L1 is right above number 1. So you have to hit your second button, 1. Then hit minus, second button, 2. Because we want to tell that third column to be L1 minus L2. Hit enter. Now you should see all the same numbers that are in the third column here on the notes should be on your calculator. So you did not have to find any of those by hand. The calculator did all of it for you. So after you find your L3, now you have to do your 1var stats. So we're going to hit our stat button. We're going to go over to calc. Hit enter for number 1. Now you must tell your list L3. You have to change it from L1 to L3. If you don't, you're going to be running all the stats for the first column. You will not get the right numbers then when you go through and do your test. So we have to do second 3 and calculate. So there are all my numbers. Those numbers we do not use yet. We now can run our t-test because the calculator has saved all of these numbers in it. So when I run my t-test, it will have the x bar and the s already in there for us, and the n and all that. So we're going to go then, stat over to test. Now it's going to be the t-test again. So the regular t-test for number 2, hit enter, and you will see all those numbers now have popped up for X bar, S, and N because they're saved in your calculator. You must do all of those steps for those to be in there. So now we've got to plug in our null. Our null is 0. So you're going to go down and type 0 here. X bar, S, N. Now we have a greater than. And go down to calculate. So here's all of our numbers. So T is 4.36. P is 0.0012. So we are going to compare then that with our alpha. And we are less than. So if we're less than, we reject. So now we can write our sentence. At the 1% level of significance, there is enough evidence to conclude that the counseling sessions reduce the average anxiety level of patients about to undergo corrective heart surgery. So again, these are going to be a little bit longer to go through. So when you go through these, you need to make sure you're hitting all the parts. So I'm going to have you look at the next one here. So if you need to go back and look at stuff, I'll read it with you. Now, in the chart here, it says difference. You do not have to fill in the difference. You can do it all in your calculator, so you don't have to write anything down. Calculator does it for you. So for this one, you are looking at, do educational toys make a difference in the age at which a child learns to read? To study this question, researchers designed an experiment in which one group of preschool children spent 2 hours each day for 6 months in a room well supplied with educational toys, such as alphabet blocks, puzzles, ABC readers, coloring books, featuring letters, and so forth. A control group of children spent 2 hours a day for 6 months in a non-educational toy room. It was anticipated that IQ differences and home environment might be uncontrolled factors unless identical twins could be used. Therefore, 6 pairs of identical twins of preschool age were randomly selected. From each pair, one member was randomly selected to participate in the experimental group, the other in the control group. For each twin, the data item recorded is the age in months at which the child began reading at the primary level. Assume the distribution differences is mound-shaped and symmetric. Using a level of significance of 5%, test the claim that the experimental group learned to read at a different age. So again, I want you to pause the video, put your numbers into L1, L2, find your L3 using your difference. Then you have to run your 1 var stats for L3. Then you can run your t-test. So pause the video, see what you can do. Okay, so going through our problem here, you need to put down in the experimental group, that's your L1. The control group is your L2. I'm going to do all that stuff first. So we're going to go to Stat, Edit. Again, go up and clear out everything. Okay. I'm just double checking all my numbers. Now remember, we're going to go up to L1 or L3, sorry, and do second 1 minus second 2. So L1 minus L2, that should be your numbers then for that column. Then you had to run stat calc 1var stats. You must tell it L3. We're going to go down to calculate, hit enter. Here's all my numbers. Now you can run your t-test. So we can go stat, over to test, run our t-test. Again, you must do your 1var stats before you can run that t-test. Now we are saying that these two groups are learning at a different age. So we're not saying one's greater than, one's less than, anything like that. We have a different age. Our alpha is 0.01. Sorry, 0.05. I'm looking at my wrong problem. 0.05. And then we want our mu d. So again, mu d is always going to be 0. Now for this one, you're looking at your two groups, and we're saying that it's different. It doesn't matter which one goes first or second as we go through this, because we are just saying it's different than 0. So we're not looking at one group's greater than, one group's less than. It's just the two are different. Now we want to go through and run our test. So I've got 0 for my mu sub 0. And we are different, so doesn't equal. And calculate. So for our t, I've got a negative 2.65. For your p, 0.04. And then I have 5.7. So we're going to compare that with our 0.05. We are less than. Remember, if it's less than, you reject. If it's greater than, you fail to reject. So if we reject, then we say there is enough evidence. If you fail to reject, that includes the not part in it. The 5% level of significance, there is enough evidence to conclude that educational toys make a difference in the age at which a child learns to read. So again, when we reject, we don't have the not with it. When we fail to reject, that's when the not's included. It's the exact same sentence either way. Either you have the not or you don't have the not. Again, as you go through these, make sure you follow your steps. L1, L2, subtract in L3. Then you must do the 1 var stats for L3 first. Then you can run your t-test through the data. When we go through and write this, it's not mu, it's going to be mu d because you're saying the difference of the two. It's always going to be 0 on the right. So for your null, every time if you're looking at paired differences, mu d equals 0 every time. For your alternate then, it's going to be mu d either is greater than, less than, or doesn't equal 0. Everything else follows from your calculator.